don't want to be annoying speaking slowly, but with a round of introduction and expectations, what you're going to see there. So if you see around here, of course, to the notion, and I come back to the agenda in 1 second, the topic of this breakout is transparency and accountability in AI, with liability will follow, of course, shortly behind the latter term. And to that, I'm happy to greet the guest speaker, Dr. Markus Schmitz, the CIO of the German Federal Employment Agency, who will give us a bit of insight that actually feeds with the overall title, what can governments do? And I'm more than happy to have some to actually speak what they really do. The same goes, since I'm not alone, for Yannick and Chandra, the two colleagues of mine I brought, and who will speak about tools that can actually feed into transparency, explainability, and insights projects report, showing what Enrollment just highlighted, that there is, or we did develop a huge technological step that actually can help us with explainability and transparency and that realm. So the other news of that is that means that for the next 45 minutes or so, you will talk with me, Sebastian, the head of AI with the consultants of the Capgemini group, the portfolio leader as well for our AI and data-driven offering. So if you go back to the agenda and give me a number count, I think we should be fit to start, right?
Yeah, it seems some people have a wrong or previous version of Zoom and cannot choose, but it's little by little filling up in all groups, so let's go.
Yep, that was an issue in the preparation. So again, welcome to the colleagues. The schedule here is a little introduction by me. You will see a Menti coming up in 1 second. Maybe that's what we can use the time on. Particularly welcome again to Markus Schmitz here before you see tools, and we will close with some conclusio. Hopefully with some better time management, at least we try here to the best to keep it up to that. So Melina, if you move to the Menti, please. You of course saw the one before, and what we like to pick up on that is, of course, we could ask a lot of questions in the standard realm. Can it ever be, will it ever be explainable? We want to, since we have an action title, what can governments do, want to have a very normative question and asking you, should it always be? And that is a tricky one, because in the development, you see, if I elaborate that question really quickly, we have, of course, the big software vendors who have a closed shop AI, but you will also see government agencies who haven't got the biggest interest that, let's say, the law enforcement algorithms get cracked, or everybody knows what data they feed on, so it probably can be palpitated to a different notion. So I wonder what you put up here as results, and as always, you are free to use the chat to elaborate a bit more on what we see in there, and start a vivid discussion about it.
I think we can mostly see a consensus here.
We can, and of course, as I said, you know, there is this reflects pretty much a discussion going on out there in the market or the committees, where we see a big share of parties or private citizens that go for complete explainability on one hand, and the other ones, of course, I mentioned law enforcement, security, also vendors, which feed on the criticality. But again, I'm more than thrilled to see the lines of interpretations of views that happen in the chat, and of course we will have them as a takeout. So if you move ahead, thanks, Melina. We might want to go to a few opening words and setting the stage of what here is up to come. And probably, and you might have heard, and I was, or in preparation, to be honest, we were a bit stumbling upon that the ethical AI discussion would immediately go to data privacy, to misuse, to God knows what. But setting the stage, I just want to reinforce that this is about AI for good. And I guess our minimum line of consensus here is that we are all advocating such technology that would help, that could do good, that supports us, that drives us, that makes our life easier. You know, I like AI having done research for me. I certainly like an AI robot to take out the trash for me. And that being silly examples, we might see that at scale. And all these wonderful areas where we can use technology to do good things. And without going everything into detail, you saw the beautiful clean ocean as a motivator in the beginning of this session. I just want to know that this is not for granted. It was in the chat before, you know, AI in that way behaves like any other technology, whether that's IT or a simple hammer. You can use it to do good things, you can use it to do bad things, but the hammer per se is paradigmatically neutral. So if you move ahead, that means, and that's what happens to us a lot, there will be the skeptics, there will be the naysayers, and they will be the ones to point it out. And they are perfectly right in that matter, that there are concerns about privacy, about security, and there are very eloquent hacks out there, particularly for AI, that little people can follow on. Think about machine discrimination, or what happened to autonomous driving with just one dot on a traffic sign, and the image recognition would mistake such a traffic sign. So what it boils down to is our point of responsibility and accountability for it. So and this differs probably a bit from standard technology, that AI is not that straightforward in terms of design and outcome, because the middle layer of it is data, which has implicit tacit knowledge about us in it. It has norms, it has value, it has behavior. So it quite differs between what an AI observes and what it should observe. So there is a big responsibility and teaching, and there is, of course, the course of accountability. Next one, and this is probably one for governments to do, not the next slide, the point there, sorry, Melina, is about monopolies.
I'm always looking for keywords, you know, but this time
my bad, yeah, my bad. Actually funny. So there is no second place in AI or in this technology. You know, why use a different search engine than Google? And that largely differs than going to your second favorite restaurant. Let's say if the first one is too crowded for your taste or for your intention this evening. And that is a core difference that we might want to observe and have a look at. And of course, the last one is awareness and workforce, either perceived or objectively. That of course we want to make, you know, while we observe, while we gather data, we do just that. We observe, we surveil, and the question is raised: what are the implications out of it? So, you know, the old drill between the neutrality of the gun and the person holding it. So now the next slide, Melina, and I make this quick since it was already mentioned that there, of course, this is not crystal new, or this is a vivid field in discussion. And while you see multinational organizations coming up with criteria, a lot of overlap we see here, probably with a big term in notion, not only that the EU uses ampersand and the OECD uses commas, but in grouping these. And of course, that gives different notion to what you just heard, that the EU is preparing legislation on that. I wonder how this goes for purpose, but I'm very much looking forward into the accountability and transparency measures to see that upcoming. The same is for OECD, which goes to the similar values and the ones we are pursuing here. So a bit on the stats, I'm seeing this is something, sorry, one ahead, you have been there, is that this is not something that is made up in the ivory tower, luckily, because this is something we perceive every day. And not only governments do, individuals do. We are bound to it by our private experience, whether that from shopping or driving. So one day or the other, almost everyone who uses a smartphone or encountered with an AI engine has experienced some AI issues. And in the beginning of social media, I remember well, someone asked me, your connection is not active, what happened to them? You know, what a spooky question is that by a machine? And you see on the counterpart that this hinders people actually to use it and do the wonderful things that we drafted out in the first slide, because they simply do not trust it. Like now, they don't install the Corona app because people don't think it's 100% safe. So there is something urgent we need to do about it, which brings me to the last slide. And hopefully, you know, this will pass to Marcus Schmitz and saying there are things out there. Are they well known? Perhaps. Could there be done more? Maybe. But, you know, it's not that there is nothing, that our institutions are doing something. Pôle emploi in France includes not only their employees, but job seekers, what can be done to use such algorithms. There is the PES on the European Union level, which includes the workforce actively in following their guidelines and implement suggestions. Sweden has a wonderful problem, and I can continue about the city of Barcelona, asking people and recommender engines what to do with car-free spaces. So it's out there. And of course, it just brings us down to have one particularly more detailed, and I'm happy to pass the word now to Marcus Schmitz and have a tangible example on it. Thank you.
Thank you very much, Sebastian. I hope you can hear me. Hello.
Just fine.
Great. So thank you so much, and I'll just jump in. Thank you so much for inviting me over to this session. And what you've just mentioned is really at the core of what we are heading forward to. I'm Marcus Schmitz. I'm CIO of the Federal Agency of Employment. I have been on the business side for many years. I'm now on the IT side, so I'm actually sort of covering the whole operational and technical field. And our mission really is within the Federal Agency of Employment to bring people and work together on the one hand side, and on the other hand side, of course, to provide benefits for unemployed people and also for children and families. So this is what our main goal is. And as you can imagine, as a public employment service, we have an tremendous data lake. And the question really for us is how to make use of these data in a responsible manner. To be honest, within the public sector, I would say if it comes to AI, we are right in the beginning. So we are not that far as we could have been. There's a lot of sort of reluctance investing into AI solutions. There's a lot of skepticism, and so the really thing, or the main sort of object really is how to proceed and how to get first progresses. So I would say AI for good is easier said than being done. And I just give you an example from our own company. When I started here as CIO, we had a first AI pilot, which was aiming at predicting the risk of getting long-term unemployed. I thought it was a tremendously good idea to start with that topic. And it was actually one of the biggest failures we had, because we had a very good algorithm. But what we failed to do is we were not accountable. We were not sort of transparent on what we were doing. So we actually didn't really take into account how important it is, first of all, to have a good idea of what is sort of the ethical standpoint of your own company. So I would just jump to page number 14, because when we started with this, I think I can go that's great. So what we did our homework then. So we started all over again and said, okay, we're going to take that back into the garage. We're going to restart it all over again. And the first thing was that we specified our own ethical values, and what we here discuss amongst the title of transparency and accountability would be explicability for us within the federal agency. So we have the 5 core values derived from the OECD and EU papers. It's beneficence, it's non-maleficence, it's autonomy, justice, and explicability. And we said, okay, this is sort of our sort of starting point from where we're gonna want to sort of start our first projects, and we established an institutional framework. We developed a process, which I'm going to explain to you, because my main point of view really is that you have to fulfill the criteria and the values along the whole value chain, not only once at the beginning or in the end, but it's a continuous process. And if you jump on to the next page, you will see what we have been doing. We have defined within sort of the federal agency, first of all, what we call sort of the value chain of AI, saying we really need to have a good idea from the idea over the use case stage, the prototype, the modeling, until the end product. We have to safeguard that we are really sort of transparent, accountable, and that we fulfill sort of all those things I've just mentioned with regard to our ethical values. So we said, and this is something that was mentioned in the plenary, first of all, we need trust and excellence. So we said we need what we call data ethics committee, which actually sort of is going to be represented by the major stakeholders from the different parties within Germany, like the trade unions, the employers' representatives, the public. And this is sort of represents the trust into AI solutions we are going to develop. And then we need a data ethics expert team, which we're going to run, which actually stands for excellence. So for the technical, for robustness, for sort of a good sort of practical sort of implementation of our sort of AI solutions. And so what we actually have now been doing is that we're saying we're going to safeguard along the whole process that sort of our ethical principles, we're going to oblige to them. And we're going to have different, you can see milestones between the different phases where we're going to have sort of checkpoints, where we're going to review whether sort of we are still on the right track. And in order to make sure that sort of transparency, accountability, and all those ethical values we adhere to are being safeguarded. And just to give you a sort of an impression of how we're going to proceed, and if you go to the next slide, I'll just give you a very brief example that as you sort of, no, just the one beforehand, please. Yeah, that's perfect. Thank you so much. You can see here sort of our value chain when we go into the development of AI solutions, and you can see sort of the different, on the one hand, the different aspects when it comes to ethical principles, but also business considerations we have to take into account when we're going to value sort of whether a good idea sort of is going to pass the gate to the next stage, like to the use case stage or to the prototype stage. And you can see that accountability and transparency become more important the more we actually get into bringing sort of AI solutions into reality. And what we are now doing is we have sort of defined a few first topics we're going to cover. and we are now setting up the expert teams and the ethics committee. And we're going to have sort of the first now topics we're going to sort of follow along this value chain. And what we have decided within our companies, and if you come to the next slide, I can just briefly show you, that we say we need an assessment by the product team with support from the data ethics team, whether sort of a use case we are developing is critical or not. So the more critical a use case is, the more attention we have to pay for it when we go down the line, especially from the prototype to the modeling part and bringing sort of out the first AI solutions. And this is actually where we failed when we had this initial sort of test of predicting long-term unemployment risks. We actually didn't take that into account. So that's the reason why we stopped at the prototype level. And we actually now really want to sort of have this sort of very practical approach when it comes to bringing sort of the AI ethical principles, which might be quite abstract if you're on the EU or OECD level, sort of into the operations on an everyday level. So this is how we're going to start doing that. And I just brought two very quick examples, and then I'm going to stop because we have some more very prominent speakers following me. The first thing is where we're going to implement it is the next slide. We have, as I told you, the child benefit system, and about 10% of the German domestic gross product go into that those child benefits. And we have the first AI solution. It's one of the use cases when people go to university and you have to prolong sort of your applications for child benefits, and we need the university certificates from all over Germany. So we have a trained model with about more than 600 German universities that actually, when you upload your prolongation application within our e-service portal, that actually gives you a prediction of whether the certificate is correct or not. So this is sort of the first approach we have been doing. It's very successful. We have very good usage rate. And we are going to implement that what I've just described on that first use case. And the second one is on the next page, is that we are working together with the Institute of Labor Research, which is a part of the federal agency, on a model to automatically extract job offers from the internet in order to have a full-size overview of the demand side on the skill level. And this is something where I can see that this value chain I've just explained is going to be very relevant, because we can see already that many of the stakeholders have questions how we're going to proceed. And this is what is going to start within the next month. So this is the first, I think, big use case, which also is in the heart of our operations. The questions you have just mentioned in the first instance was, do you always have to explain sort of, or is it just dependent on the use case? We see that the more we get into the core of our business, so the more we go into this topics like this, the more relevant it becomes to be very transparent about how you proceed, what your solutions are, and that you show that you're responsible and accountable for what you've been doing. So this just as a very short sort of impulse from my side, and I'd like to thank you very much for your attention.
Thank you. Maybe one last one, since I see in the chat that Daniel talks about context. Marcus, well, you said the first one was a failure, and showed now successful things. And I wondered to the notion that your thinking didn't really change. Was it the context, or did the world change and is now ready for your ideas or for your applications? Or did you adjust a bit yourself as well to tweak the notion?
I would say it's just that we really changed on how we proceed and how we deal with these topics. We were just nerds, like we were so enthusiastic about the solution, really, that we are quite naive when it came to thinking about what the different stakeholders awareness is. And I think this is actually a mindset change that we actually undertook over the last months. And I would really think that is more important than that the world around us changed. I still see that within the public sector, there is sort of a lot of skepticism when it comes to AI solutions. I can't explain why, but it's still sort of people are very scared. And so I think it's very important that we invest in trust and in trustworthy solutions. So I think it's on our side to convince people that what we are doing is good, is just, is trustworthy.
Thank you. Very interesting to hear about that. So I seen Yannick turning up his video, and we are very much looking forward to you switching on your mic as well and tell us what's out there in terms of tools for explainability.
Okay, I'm taking a hi. Can you hear me?
Yes.
And I can't seem to be able to share my screen. So if Melina yourself want to go on sharing the presentation. Okay, so while you show it, so basically, thanks very much, Marcus, for this presentation of a concrete case of applying explainability and ethics, and we see that it's a mix of both processes, of ways of doing, and of technology. And here, we're together with Chandra, we are going to talk more about the technology and the actual techniques that are used for explainability. I will go more with the techniques, and Chandra will illustrate with some use cases, some real work we've done at Capgemini. So if we go to the next slide, we find that the reason for going to explainability are basically because we want to have a trustworthy AI, we want it to be lawful, ethical, and robust. And for all of this, we need explainability. But then the question is, why do we need explainability? And we need to ask this question because we want to know what is the form of the explainability, what form will it take? And indeed, also to understand to whom will you be providing the explainability. And typically, a lot of the explainability at first, no, could you stay first? Thank you. A lot of explainability right now.
My laptop is...
Sorry? A lot of explainability.
My laptop was just bugging, I'm sorry.
Okay, no problem. A lot of explainability, at first it was more for data scientists and ML operation, people who want to discover and who want to improve machine learning. And that's a good use, but that's not enough, because typically users of AI systems, they need to have some kind of control and justification, and managers also need to have some control. And also for clients or for citizens, as well as for regulators, you need to show that you are in control and you need to justify. So really discover, improve, justify, control are the four main areas where you'd like explainability. And for now, mostly it was on the discover and improve, or for the technical persons doing the modeling. And we are going to see, we're seeing more and more a move towards explainability for justifying and for control. If we go to the next slide, we see that explainability has been it's seen as very different depending on the sector and on the use case. And typically, we don't need the same level or the same depth of explainability depending on the exact use. And for systems for which you don't really need to provide any justification, like recommender system, you can have quite low explainability. For systems like rating, fraud detection, and regulation, you need very high explainability. And traditionally, the problem we have is that explainability has to be as a form of compromise with accuracy, because traditionally we've seen models which are quite high in explainability, very simple models which are very explicit, but then which are prone to be quite poor in accuracy, in performance. So basically, you can get something which is very explainable, but not so much useful. On the other hand, with the new machine learning techniques, we're seeing things which are very performant, very accurate, but which are at first very low in explainability. So of course, we want to get somewhat both, or at least a good compromise. And this is where we go to the next slide to examine which are the types of explainability we can get. And so if we take two axes, we typically have two kinds of explainability we can provide. On the horizontal axis, we've got black box explainability, which is explaining a model without looking at it, and white box explainability, which is knowing the model. Traditionally, we've seen very explainable models for credit risk, for example, were provided by a very simple model, very explicit and pretty weak. And now there is a whole area of research, and we've seen a lot of improvement towards getting more performant models, but still with some transparency. The black box approach is a bit different. The black box approach is going to take any model or any model in a class and trying to provide an explainability with only an outside view of the model. And then we have two categories of explainability we may want. We have local and global. Local explainability means that we want to get an explanation on each prediction, on each scoring, on each inference that the model is doing. So you want typically to justify to a citizen why you've taken this decision, but you're doing this explanation and this justification one decision at a time. It helps a lot in the relationship with the public, somewhat with the regulator, for the manager, but it's not the whole story. Because in some situation, and again, it's not for all cases, you need to have a more global view of the model, a more global understanding. And then you need to go to some devices which are providing a global view of black box explainability. And then you've got mostly methods for which you are displaying some trends in the system, displaying the response of the score of the model to changes in variables. In the next slide, I'm going to get a bit deeper in how these models can work, this type of approaches can work. First with something very graphical, and then with the typical approaches we're using. So let's say typically that you want to recognize an image of a dog. So today it's not a cat, it's a dog. And you've got a learning process at the top where you're learning what is a dog and what is not a dog. And then you're providing with a new image, and okay, it recognizes that this is a dog. But now we want to know why we have recognized this is a dog, and specifically we want to know which are the regions of the image which have been used and which have been the more significant for predicting that this is a dog. Thus we are going to mask the image, to mask part of the image, and we are going to infer that if after masking some part of the image, then the probability that we predict it to be a dog decreases a lot, then this part is important in the prediction. So let me rephrase again. If I'm masking a part of an image and then I'm not so sure it's a dog, then it means this part is important. And you see that here we can see the various parts of the animal which are used for that. And these are very practical uses, because typically we've seen some example of animal recognition again, where we were trying to determine where there was some animals on the photographs, and we found that we learned to recognize sheep because there was some green around them. So if you don't care, that you can learn to recognize some type of animal or some type of object or some type of phenomenon, not from what we would recognize of the phenomenon as a human being, but by external clues. And that's typically what this exercise of masking part of the image can help us prevent. Now, if we go to the next slide, we see another technique which is quite popular in explainability, in black box explainability, and which is indeed very well founded mathematically, which is not always the case with machine learning techniques, but this one is based on information theory. And basically, for each prediction, it's calculating weights for the various input variables that are being used. So you can see an example on the top right. So the diagram is the kind of the distribution of the input, of the weights of the input variables for the various individuals in the sample. So we see that we have a lot of red prediction, for instance, where the weight is positive for the very first variable, and we've got a lot of negatives with negative weights. And based on that, we can understand how one prediction was done, and specifically which variables were important for this prediction. And for instance, again, going back to credit scoring, we can determine that maybe for this individual, the salary was important for the prediction. Maybe for this one, that's the location, or maybe some other data was used specifically for this decision. And by aggregating all of them and all of the weights for all of the individuals we have in the test sample, we can get a more global view of the importance of each variable for the decisions along our sample. So this is a very practical method, quite easy to use, with some drawbacks, especially that it is quite sensitive in some situations where you've got correlation, but mostly it's providing you with a model added on top of a machine learning model. And that's the problem with the black box explanation. They are quite practical, but you're doing that on top of your machine learning model. So in a sense, you're not giving information on the machine learning model. You're trying to have a system that's interpreting how your machine learning model is working. On the next slide, we see another method, which is directly to use an explainable model. So generalized additive models are a class of models, and they extend linear models. Linear models are very simple. Generalized additive models are more complex, but still very explainable. Like on the curve on the right, you can see one variable which is responding to another. So the output variable, which is responding to the input variable, it's not linear, it is quite complex, but still we get a response. And when we are building the model, we are really training the model to based on on responses to variables, one variable at a time. So the big difference with black box explainability is that in black box explainability, we wanted to kind of retrieve the weights of variables. On this one, what we are doing is we are just training the model, and then this curve is really used by the model for the prediction. And for the regulator, for the managers, that's very important, because you can really understand what the model would be doing, even in cases you've never seen before. You might have some cases where you don't have any sample, and still you can understand how the model would behave. And sometimes it would behave correctly, and sometimes it would behave in really unexpected ways.
Yeah, so coming to the manufacturing industry, so this is again related to, it's not anything related to, transactions or regulatory bodies, but the application is totally different here. In this example that you are seeing here, like there are some kind of titanium recycled items received by an organization, and they want to reuse or recycle those materials back into the manufacturing, so that new titanium ingots can be manufactured. So the first objective is to find if that recycled item can be used at all based on the composition that it has got. So once you build a model, then an optimization model is built over that, maybe using heuristic models like genetic algorithms or harmony search algorithms. So with that, you can determine what compositions of these materials that have been received can be used to produce the high quality titanium ingots. So the optimization algorithm, again, after you build it, again, the question comes, which compositions of this titanium? Is it carbon content? Is it nitrogen content? Or is it titanium or chromium? Which component or which elements are important for improving the quality of the final titanium ingot? So that's the application. So for that, over the optimization algorithms as well as the machine algorithm predictive algorithms, you can apply these Shapley values, and you can apply these techniques in order to determine which factors are important, so that you can filter out only those ingots and you can reduce your cycle time to produce your ingots. So these are the two examples that I could present today.
Thank you, Chandra. I suggest, yes, Melina, you were on the right track. While we come to the conclusion and Q&A, I would suggest that we have a lot Menti to fill out, and we are collecting questions from the chat, and warmly take the opportunity to ask Marcus, Yannick, Chandra about the slides, or me if you care, for the slides we presented. Melina will put up the last Menti of this session. And we will see, of course, we will see up a bit of measures that we briefly touched, if you go back. So, of course, what could obviously a countermeasures be within a public or private organization, but what are viable measures? Would it be the tools access you have seen, technical inspections, probably, certifications you see at the end? Is it more a charter within the organization, or a corporate governance that you see? So what do you think are viable measures to tackle transparency and accountability topics? And I got one for Yannick or Chandra, and saying, with the explainability tools you have at hand, they seem sound and well, as a feedback I got here, saying thank you. But the point is, coming from Donny Schwabier, how do people react? That is not a stone cold left or right decision, but that algorithms in AI work with probability. So you are not 100% right, but you have, let's say, an 80% confidence level that this is the likely right answer to be, and there remains uncertainty. Do you have experience in that?
Yeah, and that's a very interesting point, because we've seen a study recently showing that, of course, machine learning algorithms generally are providing probabilities, but typically we are doing the same. When we're evaluating a situation, we don't always have all the information, but we are all doing some kind of a risk or probability calculation, and we know that. And the point of the study is that even in cases where we know that the algorithm is better than a human being, or even much better, then we ask more from an algorithm than from a human being. So typically, deeply in human psychology, something like we prefer a poor or not so good human decision than a very good algorithmic decision. So that's really a problem of psychology, and we are sure encountering that in our work and projects. And that means there is some special efforts to make for justification for user experience. And it's a lot about the user experience with an AI-based system.